Hello guys, welcome to another lesson on our lecture series on further calculus 2, that is integral calculus. Today we are going to look at integration of functions using partial fraction decomposition. We apply partial fraction decomposition in integration when dealing with rational functions, specifically when the integrand is a proper rational function, that is, a fraction where the degree of the numerator is less than the degree of the denominator. Note also that whenever you are solving integral calculus involving rational functions, check if the fraction is proper. But when it happens that the degree of the numerator is greater than or equal to the denominator, then you need to perform a polynomial division first. Actually, we are going to look at example on that. So without much ado, let's take our first example. We are starting with this simple problem here, which says evaluate integral of 1 on x squared minus 1 dx. Solution. First of all, let's consider the rational function 1 on x squared minus 1, of which we can expand the denominator. This is the difference of two squares, so that gives us 1 on x plus 1 x minus 1. What we are going to do is that we are going to break this one down. So we are going to have a variable a on the first expression x plus 1 plus another variable b on the second expression x minus 1, of which we know that when we find the LCM for this x plus 1 x minus 1, the whole of this goes to this, only x minus 1, and then multiply by that, which will give us a by x minus 1. Then the same thing, this goes to this, and then we get plus b by x plus 1, which you shouldn't forget that it's still the same as x squared minus 1. In comparing, when you compare the left hand side with the right hand side, you see clearly that the denominators are the same, the numerators too are the same. The whole of this is equal to what you have here. So we can say 1 is of the same form as a x minus 1 plus b x plus 1. So we need to solve for the value of a and b. When x is equal to positive 1, when you put positive 1 here, it becomes 0. 0 times that is the whole thing becomes 0. And then it means we have 1 to be equal to b by 1 plus 1. For the x is 1 over here, and hence our b is now 1 on 2. Also, let's find the a. To find the a, then when x is negative 1, the whole of this goes to 0, then we can easily find the a. So we can say that also when x equals negative 1, then 1 is equal to a by negative 1, which is the same as 1 equals negative 2a. Hence, a is equal to negative 1 on 2. So now we have our a and b. So we can substitute that back into what we have. So our integral of 1 on x squared minus 1 dx is now a, which is negative 1 on 2 on x plus 1 plus the b, which is 1 on 2 on x minus 1. Integral of dx. Let's factorize the negative 1 on half out, and becomes negative 1 on half integral of 1 on x plus 1 dx plus half 1 on integral of half 1 on x minus 1 dx. And obviously, when we integrate 1 on x plus 1, it's going to give us a ln of that, because if you let u to be this, we're going to get 1 on u. So we're going to have negative 1 on 2 ln x plus 1 plus half ln x minus 1 plus c. So we can factorize half out, and that will give us half negative ln x plus 1 plus ln x minus 1 plus c. So we can put that together, and that will give us half ln, let's write the positive side first, and that will be x minus 1, then the negative x plus 1 plus c, and that is the solution. The next problem says we should evaluate integral of 1 on 4 minus x squared dx. So the same way, let's consider the rational part, and that gives us taking 1 on 4 minus x squared. When we expand this, we are getting difference of 2 squared, so that will give us 2 plus x, 2 minus x. This problem is similar to the first problem, but there's a slight difference. Decomposing it, we are going to get a on 2 plus x plus b on 2 minus x, of which our LCM becomes 2 plus x, 2 minus x. And with that, we are going to get a by 2 minus x plus b by 2 plus x, which is equal to that. So comparing, we are going to get 1 is equal to 2 minus x plus b bracket 2 plus x. So when the x is equal to positive 2, 1 becomes, so when x is positive 2, here is 2, and the whole of it goes to 0. So we get 4b, of which the b becomes 1 on 4. And also, when x is negative 2, when we put negative 2 here, this goes to 0. So with that 1, 2, we are going to get 1 equals, here is negative 2, so this becomes positive 4a. And with that, we are going to get a 2 is equal to 1 on 4. So now that we have our a and b, we can put everything into the integral form. So our integral of 1 on 4 minus x squared dx is now 1 on 4 on 2 plus x. That's the integral of that dx plus 1 on integral of 1 on 4 on 2 minus x dx. So factorize 1 on 4 out, that gives us 1 on 4 integral of 1 on 2 plus x dx plus 1 on 4 integral of 1 on 2 minus x dx. And you know that integral of 1 on 2 plus x will give us ln x, because when this one is equal to u, when differentiate the function, you are going to get 1, and that will still lead to the same thing. So we're going to get 1 on 4 ln 2 plus x. Then over here, when the whole of it becomes u and differentiate, you're going to get negative 1, so it means there will be negative ln 2 minus x plus c. Sorry, there's 1 on 4 here. Okay, so when you continue, again, we are going to factorize the 1 on 4 out. So we are going to get 1 on 4 ln 2 plus x minus ln 2 minus x plus c. So in simplifying, we are going to get the positive first, and that will be 2 plus x on the 2 minus x plus c, and that is our solution. Example 3. With this example, we are going to perform a polynomial division before any other thing because the degree of the numerator is bigger than that of the denominator. So this becomes improper rational function. So in doing so, we are going to get the divisor x squared plus x, then the dividends x cubed plus 0x squared plus 0x plus 1. So the x squared divides the x cubed by x. Then we multiply the answer by what we have here. X by x squared is x cubed. Then x by x is x squared. Then we subtract. This gives us 0. And this 0x squared minus x squared give us negative x squared. So I choose to drop this to it. And again, x squared goes to x squared goes to negative x squared, negative 1. We multiply the negative 1 through by x squared plus x, and that gives us negative x squared minus x. Then we subtract. We are going to get negative x squared minus x squared, and that will be 0. Then 0x minus x, and that is x. Then we drop this one, and that will be plus 1. So now that we have our quotient to be x minus 1, the remainder x plus 1, and then the divisor x squared plus 1, we know that x cubed plus 1 on x squared plus x is equal to the quotient, which is x minus 1, plus remainder on divisor. The remainder is x plus 1 on the divisor x squared plus x. And in so doing, we can consider this part 2. And this part, we see taking x plus 1 on x squared plus x, we need to factorize x out from the denominator, and that will give us x plus 1 on x out x plus 1. The x plus 1 is the same as what we have here, x plus 1. So we can cancel that out, and hence we are going to have 1 on x. So this implies that the integral of x cubed plus 1 on x squared plus x dx is now x minus 1, x minus integral of x minus 1 dx plus integral of 1 on x dx. That's what we have now. So now we can integrate. Integrating x gives us x squared on 2 minus integrating 1, which is equal to x, is x, plus integrating 1 on x gives us ln x plus our constant c. That's the solution. Our fourth and final example taking 1 on x cubed plus x. When we expand the denominator, we can factorize x out. X is common, so we are going to have 1 on x bracket x squared plus 1. We need to decompose this. So in decomposing, we can say a on the first part x plus, because we have this one is x squared plus 1, we need to have bx plus c on x squared plus 1. Take note, as the degree increases, the variable is attached to the first constant that you produce. And as usual, you can find the LCM by simplifying that expression, and that gives us a by x squared plus 1 plus the x by this bx plus c all by x. Comparing the whole of this with what we have here, the denominator is equal, and the numerator 2 are the same. So you can say that 1 is the same as a bracket x squared plus 1 plus bx plus c bracket x. Now let's try to expand this so that we can compare. So we have 1. When we expand, we are going to get ax squared plus a plus bx squared plus cx. We have ax squared and bx squared. Let's put them. So we're going to have a plus b all multiplied by x squared, then cx plus a. For us to find the a, b, and c, so you can see that this particular one is a constant and a2 is a constant. Definitely a constant is equal to a constant, so a is equal to 1. Now that we have a to be 1, we can find the b. You can say that when we compare again, a plus b equals 0. That's when we compare the x squares. But our a is 1, so we can say 1 plus b equals 0, and hence b is equal to negative 1. And also comparing those with x, c is equal to 0. So now that we have a, b, and c, we can bring or substitute that back into this. So we can say that integral of the x on x cubed plus x is now equals integral of the a is 1 on x, then plus b. We had negative 1, which when multiplied by the x, we're going to get negative x. Then the c plus 0, all on x squared plus 1, all dx. The integral of 1 on x dx minus x on x squared plus 1 dx. That's also integral. Now integrating 1 on x, we are going to get ln x. This one, we can use the u substitution to also find this. Let me work it over here. So we have, I say let u equals x squared plus 1, du equals 2x dx. Making the dx the subject, you're going to get dx equals du on 2x. Substituting into it, you're going to have the integral of x on u, then our dx is du on 2x. You know that this will cancel this, leaving us with 1 on u, 1 on 2 du, in which you can see it will lead to what? Ln u, 1 on 2 ln u. So that's what we're going to have. So it means this will be negative half ln x squared plus 1, which means because the u is the same as that, plus c. Going further, in order to get rid of the half over here, you can just multiply through by 2. So multiply through by 2, and that will give us 2 ln x minus ln x squared plus 1 plus c. C is constant, so the 2 will not affect it. And that will be, if you simplify everything, that will be ln x squared on negative, so you can divide it by this, plus 1 plus c, and that's our answer. Thank you very much for watching. Please subscribe and share to your colleagues too. This is all for the lesson today. Bye bye.